All right, today we're going to be working with absolute values. So we're going to solve absolute value equations, and then we're also going to graph absolute value functions. So we're going to do both of those today. Those are our two objectives. All right, so let's talk about solving absolute value equations first. When you solve absolute value equations, there is going to be two different cases that we have to consider. We're going to have to consider if the absolute value is positive, and then also if the absolute value is negative. So because of these two different cases, it is actually possible to go ahead and get two separate answers for the problems that we are going to be doing today. So let's look at the first one. We're going to solve t minus 1 equals 5, the absolute value of that. And the way that we're going to go ahead and do that is we're going to split it into two different cases. So let's go ahead and deal with case 1. Now case 1 is t minus 1. Notice I did not change this. It's still t minus 1, but it equals positive 5. Case 2 is t minus 1 equals negative 5. That's what we have to do with these absolute values. We got to split it into two possibilities. That will allow us to get rid of this absolute value symbols, and it will allow us to solve and actually get answers. Once we've done that, then we can solve each of them individually. So we're going to add 1 to both sides, so plus 1 to both sides. And we get t equals 6 and t equals negative 4, and those are our two answers. And we will always get two answers for our absolute value equations. So that's what we want to go ahead and do. So we write it here with these little brackets because they're not ordered pairs. So negative 4 and 6. Now here's another one. This is kind of the exception to the two answers. Notice what it equals. It equals negative 7. Now, when it equals a negative number, absolute value, if you remember, never can be a negative number. And so this one actually is the easiest problem of all. There's no solution. So the solution is the empty set. If you said no solution, that's fine. If you use the symbol with the 0 with a line through it, I would accept either one. But that only occurs when it equals a negative number. So if it doesn't equal a negative number, you have to solve it like the first one. So over here, we had to solve it by like 5. So it became 5 and negative 5. Here, with the negative 7, we can't do that. So at this point, you just go ahead and say no. All right, here's another one. X minus 3 equals 15. So we got the positive case and the negative case. So the positive case, x minus 3, again, notice I didn't change anything with what's here. The only thing that changes is this 15. One time it's plus 15, one time it's minus 15. So x minus 3 equals 15, add 3, so x equals 18. And then the same thing over here, and we get negative 12. And so those are our two different answers. We can also go ahead and take answers on a number line and go ahead and write the inequality. And the way that we need to do this is we need to go ahead and find the midpoint. So we want to go ahead and find the middle point between negative 4 and 6. It is 1, and it's 5 units away in both directions. So we can go ahead and subtract them if you want to just show that they are 5 units. But the way that we write this out is x minus the midpoint. Again, notice it's minus, equals the distance. So again, the midpoint here was 1, and the distance was 5. So the midpoint was 1, and the distance was 5. So x minus 1 equals 5. So let's try another one here. So we have negative 2 to 6. The midpoint there is 2 here in the middle. So it's x minus the midpoint. So x minus 2, it's got to be a. And then how far is 2 from 6? It's 4. So it is a. You can just follow that formula. All right, the last thing we're going to do is the second thing we're going to do is graphing the absolute value of functions. So here's this y equals x plus 3. Now remember, the absolute value function just goes ahead and always makes this positive. So let's go ahead and make a chart. So if we make a chart, we put a negative 5. What do we get when we put a negative 5? Negative 5 plus 3 is negative 2. Absolute value of that is 2. Negative 4. Negative 4 plus 3 is 1. Negative 1. Absolute value is positive 1. Negative 3 plus 0 is 0. Negative 2 is 1, so on and so forth. And we can get all these different points. And notice what happens with this. You get a V-shaped graph because what happens is absolute values can't be negative, right? So as it comes down to become a negative, it just bounces away and stays positive. So you're going to get this V-shaped graph all the time. So you just need to keep putting points in until you get that V shape, until you get that bounce, and then you know where our equation is. So x minus 5. So 0, 5. You put a 0 in there. 0 minus 5 is just 5. 0 minus 5 is negative 5. Absolute value is 5. 1 minus is negative 4. 2 is, and you get 5, 0, and 6, 0. Now notice what they did here. They set it equal to 0 to kind of understand where that bounce is going to be. If that will help you to go ahead and find that bounce, you can go ahead and do that. But once they started getting the bounce up, they kind of stopped making their chart, and they got the bounce, and you can go ahead and draw it. X plus 2. Well, let's start trying some numbers. If I put 0 in here, 0 plus 2 is just 2. So we have to have 0, 2. So 0, 2 is this one, not that one. That's negative. 0. Okay, it's one of these two. Well, I'll try 1. 1 plus 2 is 3. So 1, 3, that's good. 1, 1, that one's wrong. So you just keep plugging in points until you go ahead and get our answer, which is A. Try again. Let's try 0. 0 minus 3 is negative 3, but we got to take the absolute value of it, so it's positive 3. So positive 3, positive 3, nope, nope. Try 1. 1 minus 3 is negative 2. Absolute value of that is positive 2. So nope, that's not in the wrong spot. And there it is. And that's what I have for you today.